Hi everyone, I'm going to be going over an I.C.E table problem with you so you get the hang of how to solve your I.C.E table problems. You will definitely encounter this in Chemistry 30, and I hope you do a bunch of practice problems that help you prepare. So just some reminders, I.C.E tables are used to find an unknown variable in an equilibrium system. You must use mole ratios to find the change for a compound when given the change for another. And just a reminder of what the mole ratio is, it is N, which is moles, wanted equals N wanted divided by N given multiplied by N given. This way, the N wanted is going to be W here, N given is going to be G over N wanted multiplied by NG. And right now I'm just rewriting whatever I wrote here in words. So I'm just showing you how this works. We are left over with N wanted, which is the wanted value, by dividing these two. That is how our mole ratio works. And now to begin with our problem, I will first show you what it is, and then you can try it on your own and then follow along with me later, or I can get right to it. This is a 2019 Alberta diploma problem. You can find this on the Alberta Education website along with many other diploma problems to try. So before proceeding, we should always read the information given to us carefully and also note down what the question is asking us so we don't do extra work that we don't need to. Methane gas, CH4 gas, can be produced in a laboratory by reacting carbon disulfide, CS2 gas, and hydrogen gas as represented by the following equation. Okay, pause right here. So they've given us the equation, so we don't need to overthink this when we are making our I.C.E table. When establishing our I.C.E table, we need to just input our reactants as given by the equation and our products, and there we go. Our I.C.E table has its components. I.C.E, the I is the initial concentration of these compounds, C is the change in concentration, and E equals the equilibrium value. Now, let's continue reading and see what information we can derive from the text. Initially, whoa, this is a key word, initially, at a temperature of 90 degrees Celsius, 0.18 moles of carbon disulfide and 0.3 moles of hydrogen gas are present in a closed container. Now, if you haven't already seen by the symbol here, this is an equilibrium system, and if you needed more hints, it says closed container right here, and we know an equilibrium system has to be a closed system. So let's write our values that they've given us. They've given us the initial concentration of CS2, which is 0.18 and 0.18 moles per liter. The capital M is just another notation that is quicker to use for moles per liter. And also for hydrogen gas, they've given us 0.31 moles per liter. Let's continue reading. So when the equilibrium is established, whoa, another big word here, equilibrium is established, 0.13 moles of CS2 gas is present. So we know that when equilibrium has been reached, 0.13 moles per liter of CS2 is present. We can add that into our equilibrium blocks for CS2. Now the problem is asking for the concentration of hydrogen gas present at equilibrium. So we are looking for the value that goes into this box right here. For this problem in specific, we won't really need to deal with the products, but just in case, that the products initially begin at 0 because we are assuming that only the reactants are in the closed container to begin with. The products are later produced when the reactants react with each other. Now, how can we find the change from the initial concentration of hydrogen gas to find the equilibrium? So we've been given the initial concentration of CS2 gas, which is 0.18, and the equilibrium for CS2 gas as well. To find the change, all we need to do is subtract the equilibrium concentration, square brackets mean concentration, equilibrium concentration subtracted by initial concentration, that gives you the change. Now plug that into your calculator and you should get a value of negative 0.05 moles. Now this negative means that you are reducing your initial concentration by this value here to get 0.13 moles. How do we find the change in the hydrogen gas by the change that we've been given for our C2S2 gas? Well, we need to use our mole ratio. As stated before, that these compounds are all different ratios. If it was a 1-to-1 ratio for each of these, then the change would be the same. However, it is not, so we need to calculate it. To find change, all we have to do is look at our mole ratio. We are trying to find the change of H2 gas, so we must have the 4 moles of H2 gas in our numerator, as this is what we want, the H2 specifically, divided by what we've been given. Over here, since there is no value, that means there is only 1 mole. 1 mole of CS2 gas multiplied by the change value of CS2, 0.05 moles of CS2. This is the change of CS2. Now, once you do this, you should be getting an answer of, plugging it into our calculator, 0.2. Negative 0.2 is our change in hydrogen gas concentration. So let's input that value into our table and subtract, which is pretty simple. You take the initial concentration, subtract it by your change, because this negative sign means that we are going down, and our equilibrium concentration should be 0.11 moles per liter. As you can see, we did nothing with the products in this question because it was unnecessary. If you did fill it out, just make sure you're reading the question carefully and understanding what it is asking you to do instead of doing extra work that you don't need to. The answer is being asked to be recorded in 3 digits, which means your answer key may look like this, as it did for me, and there might be a bunch of bubbles you have to color in with the appropriate numbers, but the 3 digits means 0 point, the decimal is not a digit, 1, 1. And that is your answer. I hope this made sense. If there are any questions, please feel free to reach out and ask in the comments, and also leave suggestions and feedback. I hope this helped you guys. This was one ICE table problem. I will be recording more to help you out, and have fun doing chemistry, everyone.